In this video, we're splitting one fraction into two. Partial fractions, higher level only. And the quickest way to see why anyone bothers is to look at what it lets you do next. On the left, 8 over x squared minus 4. On the right, 2 over x minus 2 minus 2 over x plus 2. Those two are the same expression. We will prove that in a minute. But the one on the left, you cannot integrate as it stands. The one on the right, you can do almost without thinking, because each piece is just 1 over something. So that is the whole job. Partial fractions is not really a topic on its own. It is the step that makes the next thing possible. And you've already done it backwards, 1,000 times. Take 2 over x minus 2, minus 2 over x plus 2. Put those over a common denominator, and you get the left-hand side back. Partial fractions is that, run in reverse. You are handed the combined fraction and asked for the pieces. Here's the shape. Something linear on top, 2 different linear factors on the bottom, and it splits into a over the first factor plus b over the second. And higher level asks for exactly this case and nothing harder. 2 distinct linear factors. And the top has to be a lower degree than the bottom. No repeated factors. No quadratics that will not factorize. If you have seen a longer version of this topic somewhere else, most of it is not examined here. Now the method, which is faster than it looks. Write it as a over the first factor plus b over the second. Multiply both sides by the whole denominator, and every fraction disappears. Then the trick. That equation is true for every value of x, so you get to pick x. And you pick the value that kills one of the terms. Choose the root of one factor. That factor becomes 0, and the letter sitting next to it vanishes, which leaves you one letter and one number. Then do it again with the other root. 2 substitutions, 2 answers, and no simultaneous equations anywhere. Example 1. Split 5x minus 4 over x minus 2 times x plus 1. So it is a over x minus 2 plus b over x plus 1. Multiply through. 5x minus 4 equals a times x plus 1 plus b times x minus 2. Now put x equal to 2, because that kills the second bracket. On the left, 10 minus 4, which is 6. On the right, a times 3. So a is 2. Now put x equal to minus 1, which kills the first bracket. On the left, minus 5 minus 4, which is minus 9. On the right, b times minus 3. So b is 3. 2 over x minus 2 plus 3 over x plus 1. And check it by putting it back together. 2 times x plus 1 is 2x plus 2. 3 times x minus 2 is 3x minus 6. Add them and you get 5x minus 4. That is exactly what we started with. Example 2. Split 8 over x squared minus 4. And straight away, something the first example did not have. The bottom is not factorized. In an exam, it almost never is. X squared minus 4 is a difference of 2 squares, so it is x minus 2 times x plus 2. Now the same routine. 8 equals a times x plus 2 plus b times x minus 2. Put x equal to 2. 8 equals 4a, so a is 2. Put x equal to minus 2. 8 equals minus 4b, so b is minus 2. 2 over x minus 2 minus 2 over x plus 2. And that is the pair from the very first board. That is the one we said you could integrate. Also worth noticing, the top here was just a number, and it changed nothing. A and b do not care what is on top. Example 3. Split 3x plus 5 over x squared minus 1. The bottom factorizes to x minus 1 times x plus 1. 3x plus 5 equals a times x plus 1, plus b times x minus 1. Put x equal to 1. 3 plus 5 is 8, and that equals 2a, so a is 4. Put x equal to minus 1. Minus 3 plus 5 is 2, and that equals minus 2b, so b is minus 1. And here is where marks go. b is minus 1. That means the second term is subtracted. Write 4 over x minus 1 minus 1 over x plus 1. Not plus, minus 1 over x plus 1. Half the marks lost on this topic are a sign. Example 4. Split 5x plus 8 over 2x minus 1 times x plus 3. Look at that first factor, 2x minus 1. The value that kills it is not 1. Set it equal to 0 and solve it properly. 2x equals 1, so x is a half. Guessing here is how people lose the question. 5x plus 8 equals a times x plus 3 plus b times 2x minus 1. Put x equal to a half. On the left, 2.5 plus 8, which is 10.5. On the right, a times 3.5. 10.5 over 3.5 is 3, so a is 3. Put x equal to minus 3. On the left, minus 15 plus 8, which is minus 7. On the right, b times minus 7, so b is 1. 3 over 2x minus 1 plus 1 over x plus 3. And now the check. And this is the one to actually do. Pick any number that is not a root and put it into both forms. Take x equal to 3. In the original, the top is 15 plus 8, which is 23. The bottom is 5 times 6, which is 30. 23 over 30. Now the split version. 3 over 5 plus 1 over 6. 3 over 5 is 18 thirtieths. 1 over 6 is 5 thirtieths. Add them and you get 23 over 30, the same number. One substitution and it catches a sign error or a swapped a and b immediately. Example 5. And it is a trap that sits before any of the work. Split 2x squared plus x plus 1 over x squared minus 1. Here's the wrong start. Going straight to a over x minus 1 plus b over x plus 1. It cannot work, and here's the reason rather than just the rule. A over x minus 1 plus b over x plus 1, put over a common denominator, always gives you a top of degree 1 at most. It can never produce an x squared. So look at the degrees first. The top is degree 2, and so is the bottom. Divide first. 2x squared plus x plus 1 over x squared minus 1 is 2 plus x plus 3 over x squared minus 1. Now the leftover is a proper fraction, and the method applies. X plus 3 equals a times x plus 1 plus b times x minus 1. Put x equal to 1. 4 equals 2a, so a is 2. Put x equal to minus 1. 2 equals minus 2b, so b is minus 1. 2 plus 2 over x minus 1 over x plus 1. So factorize the bottom. Write it as a over one factor plus b over the other. Multiply through and pick the value of x that kills each term in turn and check by substituting a number. That is the last video in number and algebra. Next video starts a new block, functions. And it is back to standard level as well as higher. It starts with the two things every function question quietly assumes you already know. What you are allowed to put in and what can come out. Domain and range.